This week, we go behind the scenes of the construction of 3 massive concrete traffic calming devices. At an average size of over 300 square metres, there's more to these concrete slabs than meets the eye. I'm going to be taking you through every stage of the build, from the excavation right through to the finished product, including why certain materials are used and how the concrete gets tested to ensure it hits its target strength. Stay tuned, let's go. Phase 1 is the excavation. The excavation of these concrete islands is one of the most critical parts of the process, as we have to make sure that the slab is not excavated too deep or too shallow. This is done using excavators that feature GPS control and total stations which allow us to get within 10 millimetres of our target depth. Once the excavation has been completed and the heights have been checked, it is then time to place the debond layer. A debond layer is a material layer placed between 2 concrete surfaces, allowing movement caused by shrinkage and expansion due to temperature changes, greatly reducing the risk of cracking. Once the debond layer has been set, it is then time for phase 2, the form up. For a concrete slab of this size, a set of engineered drawings have been created. These drawings give the concreters all the information they require to construct these huge traffic calming devices. Due to the fact that these concrete slabs are located within a road, they are deemed trafficable, so they require even more steel reinforcing and a thicker layer of concrete. The slab that I'm currently at will be 200 millimetres thick, with 2 sheets of 8mm mesh and 16mm reinforcing bars that run around the perimeters. The mesh and bars keep the concrete fixed together to make one solid reinforced unit, which helps reduce the slab from cracking and breaking apart. There is also an aluminium key joint that has been installed at certain intervals around the island that is used to separate the slabs. The 28mm dowels used in conjunction with the key joint allow for even weight distribution between both sides of the key joint. You might also notice that one end of the dowels has been wrapped. This also acts as a debond between the dowel and concrete, allowing the concrete to expand and shrink so that you don't get damage to the concrete surface with temperature changes. 9.5 tonne of steel was used in the construction of these islands. That's equivalent to a large school bus. That's one hell of a lot of steel reinforcing. Which leads us to phase 3, the pour. These traffic calming devices will take 60 cubic metres of concrete each to fill. A pour this size can only be done with one specialised piece of heavy machinery, a concrete boom pump. The boom pump can reach out to a distance of 50 metres, making it the perfect bit of equipment for an area this large. So how does the pump work? A concrete truck will back up to the pump. The concrete will then feed into the hopper, where there is 2 pistons that work together to push and pull against each other, which creates a pressure vacuum, forcing the concrete into a steel pipeline that travels up the boom and out the other end where the concreters are working. Another key aspect in concrete is its MPa, or megapascal strength. Anything being poured in or around a road in Australia requires a minimum strength of 32 MPa. This is tested by a geotechnician who takes samples straight out of the concrete truck. They then pour the concrete into steel cylinders and let them set for 2 days on site. before being taken back to a lab, removing the concrete from the cylinders and getting placed in a tank of temperature-controlled water to cure. The first sample is tested at 7 days, while the second is tested at 28 days to ensure the concrete is on track to hit the strength that was ordered. The test is performed by grinding both ends of the cylinder flat. It is then placed inside a hydraulic press that applies a downward force that increases at a steady rate until the concrete finally cracks or shatters. The force that was used is then recorded and used to determine the compressive strength of the concrete.